all those on the handout. They may start out with first, I think if I recall, on the handout, what is the graph of a simple function like f of x is equal to x? And guys, you can plot points, you can form a table, so they're saying, what's its shape if you see f of x equals x? Now you know this is the same as saying this, if that would help. Then you construct a table, plot points like you did back in probably 5th grade, and all of a sudden you graph it, and you plot the points. After you plot a few points, you connect them. You say, oh, professor, all that looks like is this. Give a straight line, I think it's on the handout there, passing through the origin. It looks like this. And they identify this as the graph of f of x is equal to x. That's a nice straight line going through. By the way, you guys do like angles. I think it's 45-degree angles here as it goes through. It goes through the origin and has that slope to it. There's some slope to it. It's got slope next week. Another common one, a parent function, comes up. And also that calc instructor will say, we're doing calculus on this function, part B. You guys will have this one be x squared, which we all know by now. Looks like this. This is one of the easiest ones to remember. X squared, basic parabola. Something like this. And you're done. I think that was also on the handout. This is f of x is equal to, representing x squared. Letter C. One that you may have forgotten, which I think is on there, is this one. F of x is equal to absolute value of x. Two straight bars there, have x enclosed. Now you may remember that from the class, I hope you do. And if you plot points, you can always plot points. Connect, you'll get a shape like this. It's a V shape. Remind me guys, is that on the handout? The absolute value graph? A V-shaped graph looks something like this. And that's the shape of my absolute value x graph. Got that. Let's write one more. Letter D. We'll see all these again next week. Another one you may have forgotten how it looks. X cubed. Not x squared, but x cubed. And I think it's on there. You can plot points. Some students will recall what it looks like. Like this. Now let me ask for some input. I know it's on the handout. Tell me guys, basically, what does it look like? It's not a straight line. It's not a parabola. It's not a V-shaped graph. X cubed. I think it's on the handout. Does it please? Does it look something like this? And you can plot points always. And connect. And get something like this. Yes or no? It has the shape of X cubed. Now, this is to set you up for Monday. I think I see you guys on Monday, don't I? Unless you guys want to come in tomorrow. Be on campus tomorrow, gonna come in tomorrow? Yeah, I see somebody that's not, I'll be here. I just saw one hot saying yes. Oh my goodness. Friday, how about Friday? Wanna come back in? No, too much of a response. Jeez. So Monday, when you come back in, you said, Professor, what about all these? You're calling these parent functions basic graphs. They are functions. They pass the vertical line test, and there's others on the handout also. By the time you get back to me on Monday, they're going to ask us, so for example, take this one and shift it. take the graph and shift it, change it. Keep its shape, but maybe just move it further to the right, or further to the left, or sometimes they'll ask you to vertically shift it up, or shift it down, same shape though. So you're always going to start with the parent graph. And then based on what they're going to ask us to do, you're going to start shifting, reflecting, other types of things called transformations. You're going to transform the graph. That's a big part of next week coming up. At least I'll have some basic graphs, parent graphs to work with. Okay, about this much done. Now I think I better ask you this though before I leave it. Before that quiz takes place. This is a function. This is a vertical line test. Can anyone please tell me, which I don't think they identified on the handout, anyone tell me what is implied as my domain, the x-axis? What's implied as you look at graphs from left to right, always from left to right? As you go from left to right, what's implied as the x's, the x-axis? How much of the x-axis is being used on this graph as you go in this direction? How would you describe the domain of f of x is equal to x? In other words, what can I replace x by up here? Is it open? Is it closed? Are there certain numbers I can't use? Based on the graph, what do you think from left to right along the x-axis? How much of this graph, green graph, is, how's it extending along the x-axis? I know it's dropping down. I know it's going up. But along the x-axis, how would you describe that? Yes?
All real numbers.
All real numbers. As it is dropping down, but also it's moving to the left forever. As it drops down, it's also moving to the left. Now this one definitely is going up, this piece is going up. At the same time, it's extending to the right forever. So all real numbers, I'm gonna write mine like this, in interval notation, which does represent, since he gave it to me, all real numbers. Negative infinity through positive infinity. The range on this one, now the up and down, that's a little bit easier. How far up is implied it's going up? How far down is it dropping? Is that also infinity, negative infinity through positive infinity? Everything working out here. But that's a good start right there. Now let's go to the parabola. The parabola, the domain, now I'm talking about the x's. How do you describe, I know it's opening up. This one is opening up. I know it's rising forever. But how about the x's? That's what domain is, x's. And guys, as I move along, I do see it's rising, but as it rises, is it moving over to the left forever? Gradually. And does it, as it rises here, is it moving over slowly also along the x-axis to the right? So my domain might be negative infinity through positive infinity. Now let me ask you this before we start closing down here. That tells me back here I can replace x by any number I wish. And x is my domain. This says if it's open, Professor, you may replace x by any number you wish, and you guarantee it when you square it, it's possible. Is that possible? Can I square any number you throw at me? Whether it's pi, square root 2, negative 4, 6, 1/2. If you throw that number at me, is it possible for me to square it? So it's open. X is open. Now the range is not open. The range, the y, is up and down. So in terms of the y value, how would you describe what's the least or the lowest number it drops down to? Right there, 0. And it includes 0, put a bracket on it. How high up does it go? Infinity. That one's unusual. Bracket 0 to infinity for the range, domain range. This absolute value graph, not too exciting. V-shaped graph, not the curve, the V-shape here. Domain, guys, when you take a close look at it, again, you're allowed to replace x by any number you wish. By the way, is that true? If I replace x by -2, can I take the absolute value of -2? Is there an answer? If I put a -2 in there, is there an answer for absolute value of -2? Yes, 2. 0 in there? Yes, 0. 4 in there, absolute value of 4 is 4. You may replace x, which is my domain, by anything you wish. That's what this graph is implying. Range, though, something like that parabola on the side here, is bracket 0, that's the lowest it drops, and it rises forever. Last one for me right now, domain on this cubic graph. Guys, looks like again it's negative infinity through positive infinity, all real numbers. And it looks like even the range on this one, if we're correct, is this. Would you guys agree on those particular ones? Okay, so those are some basic correct. Wow. Take my time here. We're at plenty of time for this quiz. Plenty of time. Got a good start here though in chapter 1. The functions. Now on the side here, and then we'll stop. Part 2. I want us to do one little calculation and I'm stopping. I'm going to name the function for you. I'll do it first. I'm not going to ask you to grab it. Give it to you. I want you to find, close down tonight, this. F of first -3. We did some of this last time, Monday. Which merely says, please just substitute x with a -3, professor, in my function, do my calculation, and I think we'll end up with 9 subtract 3 is 6, and you're done. Is that true? Everybody with 6? Now, since I have limited time, and we'll come back to this on Monday, here's the interesting one. And I mentioned this last time, but we did not get a chance to get back into it tonight. They could actually find f of anything. In this case, for calculus purposes, you'll see next week why, but right now, f of x plus h. It says be patient, go to your function, replace all those x's with x plus h. Here goes. So now my function up there looks like this. If I replace the x, substitute the x up there with an x plus h. So I put an x plus h here, square it. X plus h in place of the x here, like a placeholder. And then they ask you to simplify it. Now, please tell me, to close down tonight, which we've had a beautiful class tonight, can anyone tell me what is x plus h times x plus h going to give you? And you had to mess up. And I know all these mess up instructors. And I will find you. If you go in one of those classes, you mess up. If you mess up, I will find you. I know all these instructors, I'll find you. Which class you're in. It ain't on me. I'll just walk in. Sometimes when you look at you, say, Professor Randy, what are you doing here? I heard something. Something about that first test in calculus. What is x plus h squared? X plus h times x plus h, be careful. Go for it.
X squared plus 2xh
So?
plus h squared.
Thank you. X plus h times x plus h. Then though, all of a sudden, they still have this on the end. It's still there. The x plus h. Is that true? And it says find f of x plus h, and I did. I went back, put it in here, got that. And the reason I'm gonna close down with that, guys, are there any like terms in this crazy thing? Can I combine anything? No. So there's a little bit more to this on Monday. I'll pick up and do a little bit more to it. Right now, though, it's like it is. Now, here we go. When I get that quiz to you, short, quiz is short. No, I don't know your background right now. I'll get to know you really well soon. Some of my students may be right on top of things and saying, oh my goodness, Professor, I'm good. But be careful. They turn that quiz in. Anyway, plenty of time to do it. You guys have everything got to be fast. I'll get correct.